My name is Matthew Adams. I work for SciSpike, which is a boutique consulting firm here in, well, not here in Austin. I'm from Austin, but drove up for the show. Today's presentation will be given in two parts. I'm giving the first part, which is Spring Data Cassandra. The second part will be given by Michael Nitschinger, who is working on Spring Data Couchbase. So I'm going to try to keep it to 45 minutes as best I can. To set your expectations for the level of detail that we'll go into for this part of the presentation, given the short time frame, I'm basically going to be describing the features, a quick overview of Cassandra, some features of Spring Data Cassandra, a demo. Then we're going to peek under the covers just a little bit to see what Spring Data Cassandra is built on, and I think you'll like that. I'll leave that as a surprise. And then one demo for that, and then that's it. Hopefully, we'll try to do Q&A at the end of the first half session if we have time, but I'll cut that off as soon as I can to give Michael time to show off his stuff, okay? So a couple things. You need to know that this project was a genesis of myself. I come from a Spring background. I was a Spring source consultant in the mid-2000s, and I know the Spring side very well. I met up with a guy who knows Cassandra very well, and together we authored Spring Data Cassandra. So that guy's name is David Webb. He's out of St. Augustine, Florida. And so I don't consider myself to be a Cassandra expert. I'm probably a Cassandra beginner. So if you have hard-pressing Cassandra questions, I'm probably not the guy to answer them, but I will take your questions down and get you the answers you need. When it comes to the Spring side, I'm a bit more knowledgeable, and I did bring the Spring expertise to this project. So with that, we'll get started. So like I said, we're going to talk about Cassandra really quick. Then we'll jump into Spring Data Cassandra, and then lift the covers and see what Cassandra is built on, which is Spring CQL. A note also, Couchbase and Cassandra modules for Spring Data are community-led modules. They are not officially supported by Spring, but they are officially anointed by Spring to be the primary distributions of the technology, okay? So, so when I say Spring CQL, I'm not referring to another module that's under the Spring official label or portfolio. It is part and parcel of the Spring Data Cassandra module. Okay, so Cassandra was born out of Facebook. It took some input from Amazon Dynamo and Google Bigtable. It is a NoSQL data store. It's distributed. It has a few interesting features in that there's no master. It's all peer-to-peer nodes. It has the always available feature that you see in a lot of distributed systems. It's fault tolerant, meaning it's almost always there. The consistency is tunable. So in two of these three things, you usually need to give up one. The one they gave up here was consistency, but you can decide just how consistent you need it to be. You can make sure that your request succeeds on just one node, on two nodes, any nodes, a quorum, which is majority plus one, 50% plus one, etc. There are many language bindings. Of course, we're only going to talk about the Java binding here. So strengths and weaknesses. It's really good for storing a lot of data. So it's used at Facebook, so of course they needed it for that. Writes are actually faster than reads, but reads are also very fast. It's very good at storing time series data. Again, it's fault tolerant, and among the peers, there's automated replication, so it's not something that you need to configure, although I believe that's tunable. Some of the weaknesses of Cassandra, and you could argue whether or not it's a weakness, it's a limited data model. So it is a columnar-oriented, table-oriented data store, but it does not support joins, and that's very much on purpose. That's by design. So you can't expect to have a beautiful normalized data model like you would in a relational database. But there are still tables, and tables have rows and columns. The thing about Cassandra, and this is both a strength and a weakness because it's built to serve a particular niche, there's no ad hoc querying. Basically, everything that you do when you issue queries to Cassandra, must hit primary keys and or indexed. I think it's and indexed columns. So if it doesn't, by default, Cassandra will throw on you, and you have to say, if you want to issue that query, you have to turn on a flag that says, I know I'm being stupid, please do this query anyway. And that flag in CQL is called allow filtering. Okay? But by default, there's no ad hoc querying. So some of the concepts in Cassandra, a key space, this is like a schema in a relational database. It's just a named space that contains tables. The legacy terminology for tables is column families, so you might see that out there in the Cassandra documentation world. It also knows about racks and data centers inherently. It is built to be a distributed data store, so it knows about things like that. A table is again identified by a name, just like in SQL, and it has rows. The interesting thing about a row is it can contain up to 2 billion columns, which is a lot, but not each row has to have the same number of columns. Okay, so that's a key differentiator from SQL. A column is identified also by a name, and it has a type. And the type space for Cassandra is fairly limited. It has your basic types, UUIDs, which are time-based UUIDs by default, text, numbers, things like that. Okay. A very important thing to consider when you're designing your tables in Cassandra is that you need to consider the primary key for the table. Now, most best practices in like JPA or other data stores, you want a surrogate key. Okay, and that's usually a good idea when you're doing ad hoc queries. But in Cassandra, compound IDs are the norm, because remember that your queries are required to hit key columns. So the implication here is that your schema is denormalized by design. You do not want to normalize your Cassandra data. You want to consider ahead of time the queries that you're going to be issuing against the data store to ensure that those tables are designed to provide the data for those queries. Okay, so each table must have a primary key, and that's the key that, just like in relational, uniquely identifies the row. Okay, the two things about that row are that it contains a partition key and a cluster key, both of which may have multiple columns, or they may not. It may be a single partition key. It may be a single column cluster key. The partition key is the thing that determines the node in the cluster where that data resides. So there's a predictive hash algorithm that Cassandra uses using the data in the partition key that sends the data to a particular node within the cluster. And again, the partition key must have at least one column. Sometimes it can have more, but it usually is one or two. The cluster key, that's the part of the primary key that again that determines where on the disk the data resides. So all the data for a particular row is clustered together. Okay. Yeah. So the interface that you have, the interface that you use to interact with Cassandra is very much like SQL. I can't say SQL because it's both CQL and SQL. It is a language very similar to SQL. It includes a DDL, a data definition language, with your basic create, alter, and drop key space and table statements, and the data manipulation language statements that you would expect: select, insert, update, delete. A couple of things to note in Cassandra: insert and update, they're syntax sugar over the same operation. It's all upsert, but they chose to present to you insert and update as a matter of syntax convenience and maybe even familiarity with SQL. Deletes are interesting because when you say delete from a particular table, that deletes the entire row. But you can actually delete individual columns from the row, because remember, not every row has to have the same number of columns. And then if you actually want to delete all the data in the table, that's called truncate. Okay. Your querying is basically what you would expect. Select your column set from the particular table, and here's where things start to diverge. You have to make sure that you're hitting primary key columns. And then if you include other columns, those columns must be indexed. If not, Cassandra will throw on you, and you have to go back to the drawing board. Or you cheat and say allow filtering, and you bring the cluster to its knees, and you go on with life. You can order. You can limit the number of results. And then that allow filtering clause, that's the thing that says, hey, I know I'm not hitting indexed columns. Go ahead and query it anyway and do a table, the equivalent of a SQL table scan, right? So that's bad. You can use star, and honestly, I don't know if it's a performance hit or not. Using select star from in most relational databases is not a best practice. We just lost our video. Oh, there we go. So saying select star in SQL is not a best practice. You want to explicitly list the columns because it's an extra query server side to figure out which columns there are and then return those. I don't know what the performance impact is on that in CQL. I can't imagine it's much. The operators are what you would expect. You can also select count for things and distinct as well. All right. So limitations and things that implies for Cassandra. Again, no ad hoc querying. So the implication is very, very important. Know your queries ahead of time and design your schema to satisfy those queries. Duplicate your data, that's okay. The assumption is disk space is cheap. We don't mind duplicating data. We're just going to store it in a denormalized form so we can get at it quickly. Okay? I've said this a few times now. All your queries have to hit primary key fields, and that's it. So that's a quick overview of Cassandra. I'm sure there's much, much more to know about it, but that's the basics that you need in order to use Spring Data Cassandra. So Spring Data Cassandra is exactly what you might expect. If, can I see a show of hands of how many people who are using any of the modules in Spring Data? Okay, about half the audience. All right. So for the other half, the key value add that a Spring Data module brings to the table is that you can define POJOs, which are mapped to whatever data store you happen to be using. If you're familiar with JDO or JPA, those are also mapping technologies for persistence. They're primarily targeting relational databases. And the difference between those and the Spring Data collection of modules is that the Spring Data modules are intended to be as lightweight as possible and allow you to take advantage of data store specifics. If there's a particular feature of some data store that Spring Data is supporting, you get that exposed to you right up front. The other APIs, JDO and JPA, they attempt to abstract all data stores under the same API. So that's the key differentiator between those technologies and the Spring Data technologies. Okay? All right, so Spring Data Cassandra is exactly what you would expect. It allows you to define lightweight POJOs and map those to the tables that you store, where your data is stored in Cassandra. Okay? It uses a familiar Spring Data repository pattern. Again, since half of you aren't familiar with that, what that means is you can simply define an interface to define your queries and things that you want to issue against your data store. And you can define that interface in terms of your POJOs. And Spring Data Cassandra will take care of generating an implementation at runtime for that interface and actually issue those queries against the data store. It's really convenient and a great time saver. Some of the things that you might see on a Spring Data repository out of the box are save operations. So all your CRUD operations save is both an insert and an update, which is convenient with Cassandra because that's the same operation. Delete any of your queries. Find by primary key, that's a common query, things like that. And then you can add your own custom methods to that interface. And again, most Spring Data modules will provide an implementation of that for you. They interpret the return type and the method name because you use a certain convention to define those methods, and Spring Data will implement that for you and return what you mean. Spring Data Cassandra supports both Spring XML and Java config. The CRUD operations, like I said, save and delete, find by primary key. So this is a key thing about Spring Data. And Michael and I were talking about some of the things that are assumptions that the Spring Data umbrella project makes. One of the things that I think is a key assumption of Spring Data is that for compound identities, you need to define a primary key class. That's also true in JPA and JDO. Okay, well, that's because the best practice in most persistence technologies is to use a surrogate key, which is typically a single ID of type long or UUID or something like that. In Cassandra, that's not the norm. The norm is compound keys because remember, there's no ad hoc querying. So you know your queries ahead of time, you design your tables to support those queries, and those tables must be uniquely identified by the primary key. And that's usually many different columns. So in order for you to not have to worry about that and have a comfortable experience using Spring Data Cassandra, we've provided basically a map ID. So we just use a map under the covers and provide you convenient methods to construct identities. Now that's not type safe, but it certainly helps. I added an issue because I myself got tired of using the strongly typed tones. And in fact, as I wrote the demo that you'll see later on, I actually hit a bug during development because I updated an attribute on my persistent entity and forgot to update its use in the map ID. So even I got bit by that. But the implementation class is called basic map ID, and I'll show you that in a minute. I did enter an issue to support strongly typed user-defined primary key interfaces. So just like Spring Data produces repository implementations for you, what I want to be able to do is define a primary key interface that is strongly typed, and then at runtime we'll provide you a convenient factory method that will produce a JDK dynamic proxy that delegates to a simple map ID, but at least it's type safe, and that's DataCast 164. Okay. This is just a little tiny code sample of what you might see using the basic map ID. You can see that there's, so import static is really the savior here. You import static, the ID static method that comes on basic map ID, and then it's a builder syntax from there. So repo is any of the repos that you'll define. Find one is a familiar method on Spring Data repositories. ID is the static method that returns to you an implementation of map ID. Map ID is an interface that defines width and allows you to just basically add keys to a map. Okay, and maybe someday Java will have a literal map syntax. That would be nice. So this is a sample when you actually write your POJOs. Most of the examples in Cassandra use sensors as their problem domain, so I chose to do the same thing. Just as you might expect, JPA uses entity. Spring Data Mongo uses document. Well, Cassandra is a table-oriented data store, so we use table. Notice it's just a POJO. There's nothing fancy about it, nothing up my sleeve. The table annotation identifies the class as persistent. These primary key column annotations are the things that you use to define your compound primary key, and they are required. There are, remember, two kinds of columns you have to define in your primary key. You have to define the partition key columns, at least one, and then 0 or more clustered columns, and that forms your cluster key. So, by the way, I mentioned that Spring Data expects a primary key class to be defined. You can still do that if you want to. You don't have to use map ID. You can use your own strongly typed ID classes, and that's just fine. We're just providing you a simple one that makes it easier and more comfortable for a native Cassandra experience. All right. Those are POJOs, and like I said, for the half of you that haven't used Spring Data before, I can simply define an interface, not an implementation, that actually lets you do the basic CRUD operations for that entity against the data store that you're using, in this case, Cassandra. So what I've done here, is defined a sensor reading repository. It extends a Spring Data Cassandra provided interface called Cassandra repository, and it's genericized, so you just give it the type of the POJO for which this is a repository. That's a bit different than most Spring Data repository interfaces. There's usually two parameter types, the entity type and the ID type. But because we're using Cassandra compound primary keys and probably using our map ID support, you're just going to give me the type of the entity. Okay. So one big thing about Cassandra repository, or Spring Data repositories, is the dynamic finders, or the declarative finder methods, right? Well, Cassandra doesn't support ad hoc querying, so we felt strongly enough that Spring Data Cassandra shouldn't support ad hoc querying, because chances are you don't want your developers to be able to write any old query and then issue it against the Cassandra cluster with allow filtering on, because it would bring Cassandra to its knees. So there is no support for finder methods that are implemented by Cassandra. There is support for custom finders, though, and I'll show you those in a minute. Okay, there are there's two ways currently to define those queries, and a third coming. The first is naturally query annotations. So we annotate a method in our interface that actually contains the CQL statement that represents the query. Okay. Another one is that you can provide those queries in properties files. So naturally, if you use the query annotation, then your developers are defining the queries, and those would be the defaults. Okay. If you define the queries in properties files, now you're starting to be more flexible, saying, hey, developers aren't the ones who are going to be writing these CQL queries. Let's just make sure that we all agree on where the properties files are, and we'll define them there. Okay. Cassandra, it was at a 1.0 status as of the Dijkstra release. It was released again with a few enhancements under the Evans release. I expect we'll see much of the issues that I'm citing during this presentation. Those should be addressed and included in whatever the next, what's the next one? Fowler after Evans. So by default, you can put them in meta INF, Cassandra named queries.properties, but you can also customize where that comes from. Okay. The queries that you write, they accept placeholders. Currently, they only expect numeric placeholders that are zero-based, so $0, $1, and so on. We will probably add named query placeholder support later on. So this is an example of a custom query where you provide it in the annotation, and it's as simple as it looks. Select star from sensor reading, in this case, where blah, blah, blah. The indexes are zero-based and correspond to the arguments here. And that's the simplest way to do it. And for any of you who've used Spring Data, that's a familiar paradigm. Okay? The only thing I'd say about storing queries in properties files is the name of the query. So it basically is the simple name of the class dot the name of the method in the interface equals, and then your CQL. Okay? And in properties files, you can use backslash to continue the line. So I just did that for readability. Once DataCast 109 is completed, you'll be able to store your queries in your XML metadata if you want to. We're going to be adding a query sub-element to the entity element. There'll be two forms. I've got both in here, but you wouldn't see this normally. A query element where the value is an attribute, and then a query element where I'm using a CData block to store the query a bit more readably. By the way, that note at the bottom is significant. The order of precedence, why does that keep happening? There we go. The order of precedence will be properties files, then XML metadata, then the annotations, okay, like most other custom APIs, persistence APIs. All right, entity mappings. Like I said, XML is going to be overriding annotations. The table annotation lets you identify the name of the table that this entity is mapped to, and then whether to preserve case. Cassandra has some very interesting rules regarding case preservation. By default, any attribute is stored in a column that is lowercase, and the tables are all lowercase. So it's like it's case insensitive. Okay? But you can say, hey, I want you to preserve case. And in Cassandra parlance, that means that's called force quoting. Okay, so we use the Cassandra term here. There's an attribute on the table annotation that says force quote. And the syntax for the quoting is a little strange, but we take care of that. There's actually a class called CqlID, and that encapsulates all the rules regarding when you need to quote identifiers and when you don't. You can also specify the mappings for fields. In Spring Data Cassandra, or all the Spring Data projects, these are generically referred to as properties. JPA calls them attributes because they could be fields or properties. I just call them fields. You can specify the column name and, again, whether or not to preserve case. Also, remember, primary key columns are important. You have to identify partition keys and cluster keys. So switch over the demo here. Is it me? Am I kicking this? I keep losing video. There we go. OK. So now we're back. Oh, I completely lost video. What the heck? OK. Give me a second here. Wow, it's completely lost. Here we go. Are we back? OK. So what I've got here is a simple demo. By the way, this demo is available in our GitHub repo, and the URL is in the slides. So what I've got here is your basic. I've also got the source to Spring Data Cassandra and Spring CQL, but let's see. What I've done is I have identified my entities here, and this is straight out of the slides. I just copied this source into the slides. I've got a sensor reading class here with a table annotation, primary key column that's partitioned. That's probably important to note. The default for these annotations, these primary key column annotations, is to identify cluster keys. But remember, you have to identify at least one partition key. If you don't, the metadata verifier that runs at Spring Data Bootstrap time, which is container initialization time, it will check your entities to make sure that they have enough metadata to be used. If they don't, the container will throw on you and give you a reason why. Another thing that's always required is this attribute called ordinal. So the order of declaration in the Java file is indeterminate when you're looking at the file via reflection. So we don't know which columns are first, and all of the columns that you define for your partition and cluster keys must be ordered according to your definition. So we need that ordinal in order to make sure that we declare the table correctly. You might be confused that I have the number 0 twice. The only thing that matters is that ordinal is used for the order among partition key columns and among clustered columns separately. So it doesn't really matter if there's overlap. It's just you have to make sure that the ordering is correct. Okay. Data is just additional stuff that's stored in this, not any partition or cluster key. And it's your basic POJO. Okay. Now, I've defined a repository as well. And I think you saw that in the slide. I'm using Cassandra repositories as my base. That gets me save, delete, find one, and whatever other methods are available there. And then I've defined one custom query. The query name is find sensor readings in date range, and it returns a list of sensor readings. All I have to do is make sure that the shape of the data returned by the query I'm issuing can fit into the return type, in this case, list of sensor reading. Okay. Show you the test code for that. So what I've done is I've defined an abstract test class that contains everything except the config. I'm auto-wiring my repository. I'm using a thing called a Cassandra template. One thing big in Spring Data Cassandra is we leverage the template idea much like the other Spring Data projects. So we take care of the boilerplate code for you. A lot of people don't know this, that you can use the Spring Data module's template class in lieu of defining interface-based repositories. If you just want to use the template, you can, and that template is actually knowledgeable about all of the entity mappings. So the interface, the repository interface are just a small layer on top of this Cassandra template. Okay, I didn't realize that until I started coding the project myself. So here's a test save. This is how you might use it in your application. So I define some data. I store them in variables here to assert later on. And I simply call repo.save, new sensor reading, and I give it the data. Then I can use my query, repo.find1. Again, here is my map ID. So I import static basic map ID.id. And then I say with sensor ID with timestamp. Again, that's not type safe, but type safety is hopefully coming soon. And I assert that it's working. Here's my test for the query. I create a bunch of sensor readings, insert them into the database. Now this is something worth noting. We have some high performance ingest methods because a lot of times you need to just fire hose data into the data store. So we've got that here in the form of an ingest method. The ingest method was designed with help from the DataStax guys, and they advise us to make sure that you're doing asynchronous inserts here as opposed to synchronous, just to make sure everything gets in there as fast as possible. And what I've noticed, we use a Cassandra unit, which launches a standalone single node instance of Cassandra here in the project. And for some reason, if I don't sleep for around a second, I end up doing queries before all the data is there. So I'm trying to mitigate that here. And I was trying to fix it here on line 92 by issuing a count against the table I'm interested in and waiting until the count is equal to the number of test entities I stored. But there's some other bug going on. So I just commented out and sleeping for a second. So now here, I've defined in my test data an enum called sensor, and we have some sensors you might expect. Tractor Beam 12, that's the one on the Death Star, and the Super Laser Death Star, warp drive, stuff like that. So for each of those, I want to find all the readings for a given date range, which is the query I issued, and it's very simple. Right here, select star from sensor reading where the sensor ID is the sensor I'm interested in, and timestamp, which is my field name, is greater than or equal to the begin date, timestamp less than, so it's a begin inclusive, end exclusive. You can code it however you want. So let's go ahead and run this. Oh, anybody know the keyboard shortcut to increase the font size of my terminal? What is it? Plus. Just. There we go. Cool. Tell me when to stop. Is that good? All right. So we're going to do, I'll just issue that single test clean. What's the name of the test? So we'll use the Java config one first, and I'll show you that in a minute. The IT at the end, by the way, is a Maven thing. IT stands for integration test, so I don't have to configure much to do that. So let's go ahead and let her rip. Cross our fingers. Hope Murphy doesn't raise his ugly head. Some of the errors and warnings you see here are an artifact of using Cassandra unit. I haven't bothered to tune it for local use here. But it's the same product we use in the builds for Spring Data Cassandra itself. All right. So what we see here is that there's our insert statement, insert into sensor reading, blah, blah, blah. Those are our ingests. And then here is my query. Select star from sensor reading where sensor ID equals blah and timestamp equals blah. So is that the query I wanted? Oh, that was one test. That was the save test. Test save, okay? So now if we want to look at test here, we can run that individually. So now we can see the queries a little bit easier. And I think this delay on startup that you're seeing here, that delay is mostly Cassandra unit, and I think it has something to do with the networking. But again, I haven't bothered to try to debug that. You wouldn't see those errors or that delay when you go against your production or test system. All right, so here are our queries for each sensor. So remember our test here was calling this finder right here, find sensor readings and date range for each sensor. And you can see there's the queries there. Select star from sensor reading where sensor ID is tractor beam, blah, 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 and so on. Okay, so that's your basic POJO support. We'll take a quick look at the Java config. And how am I doing on time? About how much? 10 more? All right. Java config. So I have an integration abstract, abstract integration test config here that the static class is extending. And that extends our Java config support abstract Cassandra configuration, okay? So the only abstract method you need to implement is get key space name, okay? That's worth noting. Yeah, question?
How do you handle dynamically added columns? You can add it to
I'll get to that at the end. The question was, how do you dynamically add columns? There's one way to do it through the Thrift API. This is not based on that. So I might have to get you an answer later on, okay? But we do have support for alter table statements, okay? Which would be the way that I would expect to use that, okay?
So how do you understand how that entity manages the fact that the rows you're pulling back have different columns?
Right. Yeah, that's a great question. Some of the column types that you can use in Cassandra are sets, lists, and maps. So if you're mapping a single entity to a table, of course the columns in that table must match the entity. So you might define your entity to have more columns than some of the rows would have. In those cases, those fields would end up being null in the Java class. Okay. But the assumption, I think the rule more than the exception is that your entities will have the same number of fields as there are columns in the data store, but it doesn't have to be true. I would just say that your entity would have to have all the columns that are in the table, possibly, so that they could be mapped if they were there. Okay? All right.
Can you support in your entities or tables, table classes, can you put lists, sets, and maps in there?
Yeah, so the question is, can you use lists, sets, and maps in your POJOs, and are those properly persisted to the corresponding columns in Cassandra? And the answer is yes. Okay. I'd have to dig in. I'd have to dig into that. Okay. You can, and if you remove the column in Cassandra, you can remove the column in the entity, but you don't have to. It just won't be mapped. It'll be null, false, or 0.
What if I don't remove from Cassandra? Can I still remove it off of the entity?
I don't know if we have a test for that. I might have to check and get back to you. Okay. I'm running out of time quickly, so what I wanted to get to was what Cassandra is built on. So let me just blast through this stuff. The XML config is what you might expect. Here's my unit test class. I'm using the context default of Spring. So here's what the XML looks like. Not a lot of surprises. There's some stuff in here to just make the project work, but basically there's a namespace. I prefaced it with Cass for Cassandra. You define your cluster, you identify the key space. One thing you want, the thing that I started to say earlier, don't use Cassandra APIs in your Spring applications to change key spaces. The idea is one session per application per key space, okay? So if you want to use multiple key spaces, that's fine. Just define them in configuration, not in your code, okay? You can do what you want. If you want to issue a use key space statement to change key spaces, you can do that, but that's not the intended use or the best practice that we would recommend. All right, so let me get to the good stuff. I think that's really the brunt of it for Spring Data Cassandra. Let me make sure I didn't miss anything. Are we good? All right, so those are the highlights. So now the thing I wanted to get to, how much time do I have? 5 minutes? Okay. Spring Data Cassandra is built actually on something we called Spring CQL. Spring CQL is to Cassandra exactly what Spring JDBC is to relational databases, okay? Because we recognize that CQL was so much like SQL, why wouldn't we want to make that stuff available for people who wanted to use Cassandra and didn't necessarily want the POJO support that Spring Data Cassandra offers, or all the other goodies. So we built it in that way. The repository contains two artifacts, Spring Data Cassandra, as you would expect, but also Spring CQL. Okay, and we tried to be careful with the names so that we didn't confuse people. We actually wanted to call it Spring Data Cassandra and Spring Cassandra, but they were too similar. So we called the lower level one Spring CQL. And that's the one that I wanted to point out that you probably didn't realize was there. You don't have to have a Spring application context to use this. All you need is your Cassandra session. You give it to the template and you are in business, just like Spring JDBC. Okay? The artifact is Spring-CQL, not Spring Data Cassandra. That's the artifact for all the goodies. The namespace for Spring CQL is org Spring Framework Cassandra. The one for Spring Data Cassandra has the data in it. Okay? So while Spring Data Cassandra is for mapping POJOs, producing repositories and all that, Spring CQL is actually for directly interacting with Cassandra using the familiar template paradigm. Okay? And by the way, Spring Data Cassandra is very much built on top of Spring CQL. Okay? So even if you don't want all the POJO goodness and all the repository goodness, you can still make use of this project using Spring CQL. Okay? Oh, in fact, note there, the abstract Cassandra configuration, that dependence goes all the way down to the configuration level. Our Spring Data Cassandra configuration classes, they actually extend the Spring CQL configuration classes. So that's very much on purpose. So the highlight is by far CqlTemplate. That corresponds to JDBC template. There's a Fluent API to answer your question. There's a Fluent API for the creation and alteration and deletion of tables. And I'll show you that if I can get to it. Another nice thing, the Spring CqlTemplate, not Spring Data Cassandra, provides the convenient Spring Data Access Exception translation. So we've translated the Cassandra data exceptions into the Spring Data Access Exception hierarchy. So it's very nice, if I don't say so myself. Let me get to the good stuff. So there's a bunch of query methods, execute methods, truncate methods, and Michael and I were talking about this earlier. Spring Data Cassandra is a heavily synchronized mentality, but Cassandra, Couchbase, and some other data stores like to work asynchronously, probably better than synchronously. So the CqlTemplate provides you not only all the synchronous execute methods, but for every execute synchronous, there's an execute asynchronous, which is really nice. Let's see. So some of the highlights, you can query, just give a single string, it will return the data stack's result set. You can query with a row callback handler. So basically, go back to some of the earliest parts of the Spring framework, which is Spring JDBC. All of those concepts are here. So I won't bother going through all that. I can show you how one works in the wild. Here's some of the asynchronous stuff. So query asynchronously, give a CQL query. It will return to you a result set future, and then you can query the result set future to find out if it's done yet or not, and for its data. The Java driver, their asynchronous callback takes a runnable, which doesn't get you much, just you get notification that it finished and no information about it. So we added an interface asynchronous query listener. It has a single method on query complete, and it passes you the result set future, which is very convenient. Okay? And of course, that's going to get called in a different thread, so remember that. Let's see. So there are a whole bunch of overloads of the execute method. The execute methods return void. The implication there is that you're issuing mutating queries or arbitrary queries that aren't selects. Selects return data, so why would you want void? Use the query methods for those. Let's see. Bulk inserts. So the template also has the ingest method. I actually was using that in the Spring Data Cassandra test I showed you. And what else? This is nice. The Fluent API for schema manipulation. So this is using a bunch of import statics. Create table foo with compact storage with a comment blah. If not exists, I can define my partition key columns and clustered key columns and columns. Okay? The order in which you declare the partition key columns and the columns determines the order in which they will appear in the create table statement. So this particular invocation will produce this CQL statement. If you notice in gray here, I've got template.execute. You can actually pass the return value of create, or these builder methods, a create table specification. You can pass that directly into the template and execute that. The template will take care of converting it to SQL. But just so you know, see that create table CQL generator? That's the thing that takes the spec and turns it into CQL. Okay, that's what's going on there. But you don't have to worry about that. Execute is overloaded to take those directly. Let me show you real quick the, why does that keep doing it? I keep losing my, you know what? I'll just call it good there. The code is up in the repository. So I'll just let you leave that as an exercise to the student to go take a look at that. But it's all there. And that's about all I got for you. So in summary, let me get going here. OK. To summarize, Spring Data Cassandra, when you want POJO goodness, when you want repository implementations automatically, things like that, then that's when you want to use Spring Cassandra. If you have a need for raw CQL usage and you want to just forego everything Spring except for that one class, you're welcome to use just that jar. Okay, and that's Spring CQL. One shameless plug. I am again from SciSpike. We do offer professional consulting and support for Spring Data Cassandra, so catch me later if you want that. These are the links to the project home, the repo, the issue tracker, all that. Support is via Stack Overflow now, like the rest of Spring. The tag is spring-data-cassandra. I do appreciate contributions. It's really me and one other guy doing this out of the goodness of our hearts. We're not really getting paid much for it. Hopefully that'll change soon with DataStax's recent influx of cash, but we'll see. That's all I got for you. And at this point, I will turn it over to Michael on Couchbase. Thank you very much.
So up front, I apologize for extensive coughing. I did grab a cold on my way here from Austria, so sorry for that. So my name is Nitschinger. I work as a software engineer for Couchbase, and today I'm going to talk to you about Spring Data Couchbase, but also I figured not all of you know about Couchbase. So who knows about Couchbase? Can I see a show of hands? Oh, quite a few. And have you used Couchbase already in a production system? Oh, great. Awesome. So for the others, I'll do, and for you as well, I'll do a general introduction about Couchbase, how it works. And then I figured I don't have much slides about Spring Data in general, because that has been covered over and over again in the session. So I'll show you something about Couchbase, and then we dig right into some examples on how to apply Spring Data Couchbase to a Spring Boot example and exposing a REST API and doing some operations. So what is Couchbase? Couchbase is a document-oriented database, and it's definitely designed for performance and scalability. So we are coming from a very cache-oriented background. This is where our roots are, and with the 2.0 release, which is now out over, I think, nearly 2 years or 1.5 years, we moved basically from a cache, persisted replicated cache, into a full document-oriented database, and we are extending our capabilities in that area. So we are not a toy company or doing some stuff. We have serious customers out there: eBay, PayPal, Amadeus, so all over the place, travel industry, banking, Web 2.0 companies, and some others which we're not allowed to put on those slides. So if you're interested in some use cases, we can talk later. I won't go into detail about that right now. So I mean, that's nice, but how can your application benefit from Couchbase? To answer that, let's do a little bit of Couchbase 101, talking about architecture. Couchbase is built on 4 core principles, I would say. I mean, there are a lot of subtle things with Couchbase, but we try to focus on 4 specific parts. The first one is easy scalability. So Couchbase basically is a cluster of many nodes which all look the same, and it's really easy to add and remove nodes from the cluster. It's literally as easy as starting a service on one node, like installing a Debian package, and then clicking Add Node in the user interface, giving the IP address, and then everything happens in the background. It's an online operation, and so forth. So we really try hard to make that very, very easy. And of course, you can also do that automated in the cloud, depending on your profiles, adding nodes at peak load and removing them in off time, so you can save money on AWS instances and so forth. We also care about high performance, and every database claims it's high performance. What I want to point out more here is that we care about consistent performance. So we made design choices inside our database and how it works when you work with it to give you consistent high performance in sub-millisecond latency. So to give you some numbers, what I would expect from production systems where the servers and the network is reasonably capable are response times in the range of 500 microseconds, even with thousands of operations per second going through the cluster. And what I mean by consistent performance is that, for example, even when you query or you want to load a document and it's not found in RAM, we store a little bit of meta information in RAM so we're able to return it very, very quickly with more or less predictable latency, saying the document is not there. If we wouldn't store this meta information, we would have to go to disk and check, and this would be slower. So it's really about consistency and predictability in performance. Another thing is always on 24/7, the whole year basically. So, and I'm a little proud of that, to be honest. I mean, you can do software upgrades with Couchbase without taking the cluster down. So you can remove old nodes and add new nodes on the fly and basically really upgrade your system to new versions without taking it down. And that's actually a pretty big deal for production systems. I mean, you can use Couchbase as a cache in front of your relational database, or you use it as a full document-oriented database, as your main database, basically. And things like that make it really, really easy, especially the sun never sets on the internet. So very often there isn't really a maintenance window anymore. And everyone who needs to do rolling deployments with relational databases, I guess, feels the pain on how to make that work without shutting down the application for a too long time frame for a user base. The other one is a flexible data model. We are coming from a cache-oriented background, so you can store everything in Couchbase. So you can take your POJO and serialize it and stick it into Couchbase, that's fine. But with 2.0 and so 2 years ago, we added first-class support for JSON. So if you want to use our views and indexing features, you want to stick JSON in the database, and then we can provide you with secondary indexing features. Very similar to what Cassandra does. So you're basically defining your index up front, and then you just query it, and you get your data out there pretty fast. With upcoming 3.0 release, I won't talk much about that today, but sorry. In 3.0 and forward, we are going to introduce, and we already have introduced in developer preview, a query language called NCL, which is very SQL-like, and it allows you to do ad hoc queries and much more SQL-like queries on top of Couchbase. Now, I mean, those are very bold claims. How does it work underneath? So it's not magic. A quick history lesson. So when Couchbase was originally named Membase, and before Membase it was named NoSQL. And key contributors at that time to the Memcached project, where some of those still work at Couchbase, they built Memcached, but what always came up was Memcached is awesome, it has great performance, but we can't save the data to disk, so if our machine dies and the cache goes down, then it's hard to warm it up, and then our main database gets flooded and so forth. So what users wanted was persistence for your cache and also replication. So that was built and eventually ended up in a product called Membase. And then sometime later, Couchbase merged with a company called Couch1. Couchbase was built, and the caching product basically evolved into a full document-oriented database with first-class support for JSON, views, MapReduce indexing support, and also cross-data center applications. You can run data centers in Europe and US, and we are taking care about a uni or bidirectional synchronization between those clusters for you. The current Couchbase Server version is 2.5.1, and the next version is 3.0. It's going to be released in October. It's currently in beta 2, and it has some optimizations for huge data sets. It has better indexing performance, improved security. So with 3.0, we can do SSL encryption to the clients, and many more. So if you're interested in what's new in 3.0, especially for you who are already using Couchbase Server, if you're interested in what's coming up, and if that's something for you, grab me later, and then we can talk about that in detail. So how does it work underneath? Every node in Couchbase is exactly the same, so there is no separate sharding server that you need to install. You just install a Debian package, which you can download from a website or an RPM, or on Windows you install an exe file. And then you just start up a service, basically. But every node consists of two main parts. So there is this I would say data part, and there is this communication management part. So Couchbase Server itself is written in C and Erlang. The cluster communication part is completely written in Erlang. Erlang OTP, it handles all the failure scenarios, adding, removing nodes, making sure the data is shuffled around and so forth. It's very resilient. It's really built for resiliency. But the hot code path where data gets put into the system and retrieved is written in C. We have a completely managed cache layer, which is actually, of course, built on top of Memcached. It's basically a very large extension of Memcached. Underneath, we have a persistence engine. We have indexing for secondary indexes and so forth. Now, if we dig a little bit under the covers, I don't want to go into much detail about the cluster management part. But as you can see here, basically, there is this managed cache layer. EP engine is our disk is our bucket engine where we do different buckets, like different databases, managing those. And then there is our disk persistence, which is an append-only file system, and it makes it very resilient as well. So if your node crashes, we can very easily recover from an append-only file system. It's very hard to actually get the files corrupted, and we can recover very easily. Because we're using an append-only file system, there is a compaction process running in the background which you can configure, which cleans up those files and makes sure to do all the housekeeping, basically. And then a little bit on the side here, there is this query engine, which basically creates B-trees for your indexing data. So you're defining an index written in JavaScript, and then we use Google V8 underneath to pass your JSON documents and build those indexes up. They're a little bit like materialized views in relation databases. So the index is constantly kept updated, and when you query it, you're already querying the created index. So it's very low overhead and also designed for scalability and performance. Now, if we want to add a node into the cluster, so imagine we have a one-node cluster. So this is our current node, and we have two application servers, Java application servers, which happily talk to this cluster. And we want to extend our capacity, so we want to add a second node. Now, what we do to make it work under the covers is that every bucket, so a Couchbase bucket is like a database, is fixed mapped on 2024 partitions. And if we add a new node to the cluster, what the cluster management part does is it moves partitions from one node to the other in the background. They get still served from the old node. And once the partitions have moved to the new node, basically a switch is flipped. The SDKs, which are intelligent, they know that they get a config pushed or they pull it depending on which version you're using. And they get notified of the topology change. So they transparently go to the new node, and you never need to take your application server down, add new IP addresses, and so forth. So the clients always pick up new configurations when you're moving along. So we are adding a node to the cluster, then we are hitting rebalance. In the rebalance operation, our 1024 partitions get split up in 512 two times. So every node now is responsible for half of the total data. And we basically doubled our amount of RAM available on the cluster. So, and the same process, of course, works if we want to scale from 2 to 4 nodes. We add those, and then we do the rebalance operation again. The partitions get moved, and then we again double the total RAM amount available. And of course, because every node is only responsible for a subset of its full document set, also the indexing has linear scalability, because since every node is responsible for a smaller part of its data, it only has to index here one quarter of the data instead of half, and so forth. But I mean, that's all nice, but how does my application access the data? Talking about data access. So when you're querying from your SDK, from your Java application, there is an operation called get, which is like a select operation in relational terms. And you issue a get with the primary key of the document. We call it the document ID. So every document in a bucket needs to be identified by its unique ID. So you issue a get statement. And then the document gets loaded from the RAM layer and gets returned to you immediately. If you want to store a document, there are 3 commands available: set, add, and replace. They differ a little bit in semantics. So set is like an upsert command. If the document is already stored, it replaces it. If it's not there, it just adds it. And add and replace, if you use add, it will work if the document has not been stored already, but if it's already there, it will fail, and replace is exactly the opposite. And the document will be stored in the RAM layer, and once it's acknowledged in the RAM layer, response is returned to the application server, and you can move on. Now, the question always comes up, now what happens if basically I kill my node and the data has not been persisted to disk, because both replication and persistence is done asynchronously. So what happens if I kill my node? What we provide from a client perspective is, by default, we will return a success if the document has been stored in RAM. But for example, in Java, we provide overload, so you can say persist to master or replicate to 1. And then the client will return you only success if your durability requirements have been fulfilled. And if they failed to be fulfilled, then you get an error, and then you can react appropriately in your application. Now, 2 other things: ejection and cache misses. So if you're storing a document, and so you're writing to your cluster, and so forth, and it could be that you want to write more data than you have memory available. Now, at some point, what the server needs to do, it needs to eject documents from memory. They're still persisted on disk, of course, but it needs to eject them so it can accept new data. what will happen is it will use something called not recently used. It's a common pattern, especially in the caching world. Documents which haven't been used in a while get removed from the RAM layer. They are still persisted on disk. But we are still keeping a little bit of meta information available in RAM for each document, so we can very quickly answer get operations and so forth. Now, if we want to read that document again, it has been ejected. So, oops, sorry. It has been ejected from RAM. So we will look at the RAM layer, see if the meta information is there. Of course, we have to go to the disk and fetch the document. If the meta information is missing from RAM, we can return immediately saying the document is not there, and you can move on. Depending on depending on the application, if you have a working set where you need everything in RAM, of course you want to make sure that your full working set fits in RAM. But for example, let's say you have a game and you know that only 30% of your total users are playing at the same time. You don't need to plan your capacity for your full data set. Just make sure your working set fits in RAM so you can serve them in a timely manner. So we provide calculation sheets which show you how to size your cluster accordingly. So we covered that. Come on. So as I mentioned briefly, our client SDKs, and we have a lot of those, are cluster map aware. So if you instantiate from your application server, you say new Couchbase client, and you work with a Couchbase client, and you add and remove nodes or failover nodes from the cluster, you never need to restart the application server because the SDK picks up new configuration information from the server, and reacts accordingly. So if you add a new node and the server tries to access the old node for a document, but it has been rebalanced away, the old node will return, well, I'm not responsible for this partition anymore. Please go look over there, and we will transparently retry, and you get the data from there and so forth. So we are trying very hard to keep your application running as long as possible. You don't need to do restarts and so forth, really keeping you up all the time as long as possible. So talking about SDKs very briefly, we have, I would say, a good range of officially supported SDKs. Of course, there is the Java one, but we also provide one for .NET. And then there is a C library called libcouchbase. And on top of libcouchbase, we have different bindings for PHP, Ruby, Python, and also Node.js. So if you want, you're free to use all of those, which also makes it very nice if you have a variety of languages in your application, in your environment. You can use all of them at the same time. If you want to start, there is couchbase.com/communities, where you can find more information about all those projects. And we also have community clients and wrappers. For example, for Java, there is a wrapper for, there's a Scala wrapper, then we have a Closure wrapper and so forth. They are maintained by the community. So if you're more into those languages, feel free to check them out as well. So talking about the Java SDK. The current version is 1.4.4, and it's been around for quite some time. We are wrapping the SpyMemcached library. Who is aware of the SpyMemcached library? Okay, so SpyMemcached has been around for, I think, 10 years now. It's one of the oldest memcached libraries available in Java. So yeah, SpyMemcached. Yeah, sorry about my accent. Maybe it's not the best one. So, and we basically wrap SpyMemcached and put our configuration stuff and view stuff on top of the SpyMemcached library. Now, that's good and bad. It has some drawbacks. It inherits some legacy, but it's also very stable and mature. We are also maintaining SpyMemcached still, by the way. It's completely asynchronous, so we will return you futures, and you can block on those futures if you want to have a blocking API. As I said, it's cluster topology aware, so if you add and remove nodes, it gets notified of that. And what's also very important, it unifies the underlying protocol semantics. So for those primary key type of lookups, we use the memcached binary protocol. For view operations, we use HTTP. The config operations are also over HTTP and a different port, but you don't need to care about that as well. You just connect to the server, and everything else gets handled transparently underneath. new SDK, the brand new one, which we're currently working on, it's nicknamed SDK 2.0. It's currently in the beta release. You can grab it from the website, and it's a full rewrite compared to the 1.x series. We built it completely on top of Netty and RX Java. So if you like reactive systems and observables and asynchronous computations, you can do that with this. Of course, you can still use it as a blocking API if you want to, but it's much more powerful. We took the chance to revamp our SDK APIs, including the Java one, going from a very cache-oriented API to a more document-oriented API. So it's very modern, and it has all of the nice things that you would expect from a very modern Java SDK. And we also, it's not here in the slides, but what we also did was we did break apart a core module. We call it Core IO, and it's completely message-oriented. And then on top of the Core IO module, we are putting a Java binding, and we are actively working on a Scala one as well. So there will be much more officially supported language bindings because of the core, which handles all of the rebalance things automatically. It's much easier for us to provide you officially supported language bindings for alternative languages like Scala, Groovy, and so forth. So if you're interested in that, talk to me later. And also, it will provide first-class support for NCL. Now, NCL is SQL-like language, and it's currently also in a beta release, and currently it's standalone component. It will be integrated into Couchbase Server in the future, and it allows you to do ad hoc queries, and it has a very SQL-like language. Actually, it's a superset of SQL. So NCL is a word play on the non-first normal form. So basically, the N1 stands for non-first normal form and query language. So that's why it's named NCL. And what it does, because it's a superset of SQL, so you can do everything like you could do with SQL, but it also has support for JSON. So for example, you can say select from, and then you can select array elements or nested elements in objects and so forth. You can do joins. You can do inner document joins. You can do you can join more documents together and so forth. So it's very powerful. We're currently working full steam on that under the covers. It will also have a brand new secondary indexing engine built exclusively for NCL. So there's a lot of exciting stuff coming up in the next year. Yeah, and because of RX Java, we also have first-class support for Java 8, so you can use lambdas, method references, all the nice things that you would get with Java 8 already works out of the box with the new SDK, but we still keep Java 6 compatibility, so you use whatever you want from Java 6 and above. So Spring Data Couchbase. Spring Data Couchbase currently is built on top of the 1.4 SDK, and actually, I think, yeah, we hit 1.2 with the release, which was announced today or yesterday. So it's part of the official release trains, and the key features, and again, I don't want to reiterate all the general Spring Data stuff because it has been covered extensively today. But of course, the key thing is you work with entities instead of working with JSON directly. With the current Java SDK, what you would have to do is you would bring your own JSON mapper. So if you want to use Jackson, use Jackson. The new SDK provides out-of-the-box support for JSON, so you can use JSON objects to store them. So you don't need to use a custom JSON mapper, but you can if you want to. But here, it's all focused on entities. Then we provide the Couchbase template, which wraps the Couchbase client object. It knows the entities. It maps Couchbase exceptions into the Spring exception hierarchy and so forth. Then we have the CRUD repository, which allows you to just define the interface, and you get full CRUD type of access to your entities. Easy configuration management. We support Java and XML configs. And also JMX support is available, and also a cacheable support. So because technically cacheable is not really part of Spring Data, but it's actually part of the Spring core, Spring framework. But we decided to put it in Spring Data Couchbase nevertheless. It uses the underlying Couchbase client, but instead of storing JSON, you can just store anything. So cacheable allows you to transparently cache any type of data which is serializable. And since we can also store it, you just put cacheable annotation on whatever you want, and then we just stick the serialized data into Couchbase, and you can use it very nicely as your cache and your main database at the same time. So talk is cheap. Show me the code. Let's do a demo, and then I think it's beer o'clock. So maybe I should make that larger. So I'll disable caching first. I'll show you that in a second. Let's do that here. So we're using Java config here, and all you have to do is you say extends abstract Couchbase configuration. We do basically everything for you under the covers. We configure SLF4j because Couchbase supports Java logging and log4j and so forth. All you have to do is provide a list of bootstrap hosts, the bucket name and the password of the bucket. Now, one very important thing about bootstrap hosts is that you only, let's say you have a 10-node cluster, you don't need to provide all 10 nodes. You just provide 2 or 3. It's very important that you don't only provide one, because imagine you're starting an application server, one of the nodes happens to be down, then you are not able to bootstrap your application properly. So provide 2 or 3. So if the first one is not available, it can try the second and the third one. And once it has initiated the connection, it will remove your list anyway and take the full one from the server side. We are connecting to the beer sample bucket. Couchbase Server ships with 2 sample buckets, the beer sample and the game simulator. Using the beer sample is convenient because we have beers and breweries stored as JSON documents. We can query them and so forth. And we don't need to come up with sample data. And the password for the beer sample bucket is empty. So we also enable the repositories for Couchbase. And now I didn't remember how I named the classes. Sorry about that. So here's our repository. Not very fancy, but unlike the Cassandra repository here, you have to define the ID of your entity, which is always a string. So in Couchbase, every document needs to have a unique ID, and it's a 250 byte UTF-8 string. I mean, you can also use bytes, but you probably want to use IDs, strings. But you're completely free how you name those. There are different strategies that you want to use depending on the application. You can use unique IDs. You can use what we call natural IDs, like email addresses. If you pick them wisely, you can very easily take those documents out. For example, if you want to log in a user, it maybe makes sense to store his email address directly in the ID, so you can try to grab it, and if it's not there, you know up front the user is not registered and so forth. So this is our beer repository, and then we have the example, how do I name it, controller, the beer controller, and this is a Spring Boot application. So we have a beer controller, and we define some actions here. So let's first start the whole thing. Or restart it probably. Yeah, one thing I didn't show you is that Couchbase ships with a very nice user interface out of the box. So if you go to port 8091, there is a cluster overview. You can see all the server nodes which are in the cluster. You can see your data buckets. And if you click on a bucket, you get a lot of real-time statistics, so you can, which provide you real-time insight into how your cluster is behaving. You can do that on a per bucket basis or on a per node basis. And actually, our user interface is very much like the operations people, because out of the box, you get very detailed information about the health of your system. For example, things like the disk write queue, and of course I don't have load running here on the system, but if the disk write queue is growing, you know you basically have more write operations than your underlying disk system can saturate, so you may want to add new nodes, faster disks, and so forth. Watermarks, so everything you need to debug your application is in here. And here's our data set. So here are our views, which are our secondary indexes. So I don't want to go into all the details, how they work, but I'll show you in a second. So let's first start with the index method. So it takes a while because we have many, many beers and breweries in our system. So it returns a list of beers here, I think 3,000 or so. Now, how does that work underneath? What we are doing here is we are using our repository, the find_all method on the repository. And the find_all method uses conventional configuration, so it expects an all, a few named all on the beer design document, and it basically looks like, let me get out of here, to the console. So here's our view. And this is all it takes to create such a secondary index. So it's written in JavaScript. So you say if our document type, and type is just an arbitrary field in our JSON document. You can use whatever you want to identify those documents. If the document type equals beer, then we emit. So we tell it to put this document into the index. And then when we query it, it's already in the index. So you can also query it from the user interface to see what's going on here. So we need to disable that. So here you can see basically all the document IDs which match the index. Now, why are we seeing the full document in here, or at least some parts of the document which relate to our entity? This is because under the covers, what the Couchbase SDK does is when it retrieves the ID of the document, it then does a very fast and efficient get lookup over the binary protocol to fetch the full document. So you never need to put the full document into the index, which would just duplicate the data, and we'll take care of that for you. Now, here we have our beer. It has an ID field, and this is required because every document needs to have a unique ID. And then we have a field name and then an alcohol by volume on our beer. And here is our arbitrary type. Also, if you store a document with Spring Data Couchbase, it will store the underscore class property with the class name into the document. So you can also use that to identify your beers properly. So just a regular POJO. What we also provide is annotations like @field, where you can give it an alias, which is very nice, especially if you have a lot of JSON documents and you want to save some space. You don't want to have the name written out all the time in every document. But of course, you want to use it in the application. You can say field n, and then what will happen is that when the JSON document gets written, instead of name as the attribute name, it will just use n, and when it reads it, it knows both formats and just uses those. One nice feature of Couchbase, and there you can also see its caching legacy, is that we support document expiration automatically. So if you specify an expiration time here of 5 seconds, and if you store the entity, it will be removed automatically from the server after 5 seconds. This is very nice, especially if you do session management and other parts, which we actually want to get rid of documents after a specified amount of time. So to the question was, if I understood correctly, can you do a more specific view query? Yeah. So what you would have to do in this case is what you would do on the server side. You would either create a new view, a new index, or you just adopt this one. So you can. But the short answer is you are doing this on the server side because the index needs to be created like very similar to Cassandra. It needs to create the index. And of course, what we could do is also we could create those JSON things automatically and put it on the server. But we also decided to not give you a loaded gun right away and say, oh, here's a loaded gun, do whatever you want, but don't shoot yourself in the foot. Because the problem is, imagine you have millions and millions of documents on a production system, and you accidentally create a view, and then it will have to index all of those documents. It will drag your complete system down. So you want to you want to separate the process of creating those indexes from querying them. It will change with NqL because NqL allows you, it has create index statements which will have much more intelligence on how to do that. But this is how you would do that. So you can say and alcohol by volume greater than 5 or something like that, and then you store it, and when you retrieve it. What you can also do is you can put more information. What you can do is you can do different queries. So it's not, you always have to get all data, but you can say, so you could put the alcohol by volume in our key, and what you could do then is query it and say, give me only the range of beers which are between 5 and 10 alcohol per volume, and so forth. So you can do that in one view. You don't have to do a lot of views for each of those. But that's more part of the server. And what you can do is on your repository, you can also define custom finder methods. So you can say find by alcohol per volume between blah, 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 and so forth. But again, this is also not dynamic. What it will do is conventional configuration. If you say find by ABV, it will look for an ABV view, and then you can provide custom query parameters to filter those properties. So since I think I'm running a little bit out of time, what I wanted to show you finally is the cacheable notation. So in our config, we just say enable caching, and we configure a bean of type Couchbase Cache Manager. And we name our cache persistent. And in our code, let's go here to the controller, restart in the meantime. So there is, I came up with an artificial service which has a method called perform task. And all it does, it sleeps for 3 seconds, and then it returns the date to string. So what this will do is, if you call the service the first time, it will sleep 3 seconds because the key long task is not found in the database. So it will do that, and afterwards, it will not only return you the data, but actually serialize. So you don't only have to return a string, you can turn whatever is serializable, and store it into Couchbase. And the second time you query it, it will load the data from the cache and return it right away to you, which I think is really, really convenient if you want to use that. So we can do that. So let's go here. I think I called it long task. So you can see it spinning, 3 seconds, and afterwards it prints this time. And if we jump over to the user interface on the bucket, you can see requests going up, basically operations per second. Now, if we reload that, it will return immediately. It's not sleeping 3 seconds. But of course, the time doesn't change because this data is stored in cache and returned to you right away. And if we go back to our user interface, we can see get operations happen. And this was the one set operation. Now, why did we see 2 in the first place? Well, because it had to do get upfront to see if it's already in the cache. It was a cache miss, so it stored the document. And for the subsequent calls, it just loaded the document. Of course, you can also provide an expiration time here, so you can say, I only want to keep it for 5 seconds or a few minutes and so forth. So again, you can use Couchbase as a very nice document-oriented database, but also as a cache. So I think we are right on time. Are there any questions? Yes? Yeah, so what you can do is there are ways to here. You can provide different keys, and I think you can customize those keys based on the params. So depending on the different params you pass in, it will use different keys to store it. So it's definitely possible. You don't have to do different methods for different keys. You can customize it on params as well. This is just a subset. So there are many more annotations supported by Spring. For example, you could have a method which evicts the cache for a specific method if it gets called. I think it's called cache evict or something like that. So this is just a very simple example. You can get much more fancy on configuration. Maybe we can talk about later if you want to get more details. More questions? Okay then. Thanks very much. Also, thanks for yes. Yeah. Thanks for reminding me. I think at 9 p.m. there is a BOF session. I don't know in which room, but it's on the website anyway, where we'll be around and you can ask questions for Spring Data. You can show us your code, and we'll be very happy to help you out and answer any questions on that one. Also, the other Spring Data folks will also be at the BOF session. Then thanks very much and have fun at the after party.